The Data Engineering Show is brought to you by Firebolt. It's the cloud data warehouse for insanely fast analytics over terabytes of data with fewer resources.
Welcome back, everyone, to the Data Engineering Show. Good to have you. So it's the second episode in a row now without the other data bro, Eldad, because he is out today, but he'll be back in the next episode. Let's jump right in. It's a total pleasure having Krishnan here today. He's a senior director of data engineering at BlackRock, and he's done everything really. It's so cool having you on. He started out as Cisco, kind of spent 10 years there, then went more to the vendor side as a principal PM at Oracle, and later as a director of product management at Greenplum, and then the kind of most recently. He's actually been, as a kind of senior director of data engineering at BlackRock. Great to have you on today, Krishnan. I look forward to talking about kind of the data challenges you're facing, kind of your background and everything. Do you just want to kind of give a quick intro of yourself?
Thanks, Benjamin, for having me. This is a pleasure. And like you said, I've been in this industry for almost a quarter of a century. So now that I think back, it's been a long time coming. But I'm really excited to be part of this conversation. I think the data space and the data explosion in the last couple of decades and all the modernization has put a deja vu into the data organization. Every day seems like a new day, but also seems like a groundhog day in some ways. So I would love to share some of the things that I've learned. And back to my background, I started off as a data engineer. Actually, it was more of a serendipity. I did my first initial project as an executive information system for Cisco for all the web-based application, and then realized at the back of it that we actually needed a data warehouse and a data model and a data cleansing and all of the things that goes with data pipelines to get that numbers right. So that was my nirvana moment.
Wow. So take us through the stack back then. How did you have a lot of options? What types of systems kind of were out there at the time? And I guess it was all on-prem as well, right?
Think about this. 1993 was when internet became kind of prevalent. Cisco was the main vendor pushing that pipelines and the routers for internet. So when I joined in 96 at Cisco, the executives used to get their reporting in Excel, right? Every week they would get, and it would be a high level number, pretty much that's it, and no other information. And then they would make phone calls to all the different departments, different groups, and then, by the time they get to a problem statement, the problems are either already solved or it has escalated to an extent that it was too late to solve, right? Whichever way it went. So the premise in 96 was, hey, we are the pioneers in internet. We should build an internet technology that can help showcase what we can actually present to the executives. Out of it was born the Executive Information System. We call it EIS, the first generation of it. And it was all homegrown. I was one of the 4 engineers, and eventually got the lead engineer there. It was based out of an Oracle ERP extract and then we had an Oracle SMP database, right? It's a large-scale data warehouse, scaled to single instance Oracle data warehouse. And it had its own challenges extending, but it was that. And then the front end was a purely web-based application. And web-based application, it was pre-Java, pre-EJB, it was all pure HTML. And what we did at the back end was we used to run this extraction process and build this data staging layer, for lack of better words, because I was not a data engineer at that time, and I would do so many things different. But we did that. And then we would run a process between that and the web server to create all these different HTML pages, because HTML was limited, right? Web configurations were very limited. There wasn't a real dynamic XML parsing. I think XML was just coming up to speed, not even that. But anyway, so Java EJB was not even part of the picture. No servlets, right? If you think about those things. So it was all pure HTML, PHP based query process. So that's that. And the expectation, since it's executive reporting, was they were looking at the overall high number and they would drill down all the way to, and by region or by product, eventually to a sales rep, to a transaction, to see where, if there was an issue, if there was a question, they could go all the way down. So the process itself in the beginning took about 6 hours for us. Interesting, and again, reliability was a whole different problem. I will talk about that later. And then the data accuracy was another level of challenges that we solved in subsequent releases. But the first version of it, for all the good things that we did, it had its own challenges. And part of it was technology and the immature technologies and the kind of band-aiding them together to make it work. And then the other part of it is, of course, we also could have gone and done a better data design process and data alerting process. So that was fun days, but it was a hugely successful endeavor. If I were to just talk about the outcome of that, the appreciation we got out of something like that, it was actually showcased by Cisco as one of the pioneering projects that helped. In those days, Cisco used to call it the virtual close. What it basically means is it used to take like a month for companies to close their book of records. Using this application, this was one of the key applications. I won't want to call it this is the only application. Using this application, Cisco said they could actually close their books within a day. So from the vision to what we could accomplish, notwithstanding all the other disclaimers like food info, it was a success. And we actually got funding to make it better, and we did do better. And the second iteration of that was a whole better concept. And I'll talk about that a little bit later. But that was the genesis of my data engineering role. Actually, let me talk about the second version of it, because I led the second version of that project, which we called eExec. And part of that project was to find a better capability, a better tool. And this came around in 2001. So if you are all aware, and if you have followed the internet bubble, and the burst of the internet bubble in the early 2000s, I don't know, Benjamin, if you were there, but I wrote the whole wave.
Yeah, I was alive, but I wasn't actively, kind of consciously, I think, acknowledging.
I was riding the whole Cisco bubble, and I still get nightmares about that, because one of my roles in this project as eExec was we would wait for the SVP of Cisco to go in and provide confirmation on forecasting and judgment, which is basically saying, yeah, I agree with this forecast and this number's going to be good. I was the one who would say, okay, it's done, click the process, right? Data engineer making sure that everything is done. The financial analyst will tell me that, and then I will make sure that the process gets solved. But I would validate that everything is working. I still remember that day it was October of 2000, some early October of 2000, or maybe, October of 2000, when there was a huge downward revision of the forecast from what I have seen in the past. So the forecast was always going up, and then it was like a fairly deep decline. I was like, something doesn't look right. But I was still an engineer. I had to get my job done. I just did it and went off. 3 months later, you saw the whole internet crash and Cisco going from its huge bubble. So I lived that downturn. And I lived it very, very vividly, both in my financial terms and at Cisco. So remember I said, we assume that this application will help executives give an early warning and give the executives a good indicator of how the business is performing. And if you wanted to do a virtual close, within a day, they can close. This application kind of didn't give that exact, it gave them good information, don't get me wrong. It didn't give them the exact alertness that they were looking for, which is something is wrong, proactively telling them that, hey, something is wrong, you're going to miss this. And there were a lot of other business reasons for that from a technology point of view. It didn't do that. And that was the next version of this. So the next 2 years, from 2001 to 2002, 2 years, I spent a whole lot of time digging into the data to understand how we missed all of these indicators, because it was a big impact on Cisco. We had layoffs, our stock prices never recovered from that. Even today, it hasn't recovered to the pre-internet days. So I did a lot of work on that. And we came to a conclusion that, of course, our engine was not a real engine. It was just a reporting engine. It was not an alerting engine. So we kind of thought that was important. And we went in and we needed a more dynamic and scalable model to improve this, and so that we can easily change some of these parameters. Toward that end, we chose a technology which eventually got called as Siebel Analytics. I don't know if you're aware of that now, but Siebel Analytics was one of the products that Siebel had brought in, and it's supposed to provide this automated dynamic dashboard creation, fast and easy, and it had alerting capabilities. It could multi-device, and this is right at the time when mobile phones and not the smartphones, just the mobile phones were getting more prevalent. Pagers, mobile phones, dynamic content, PDAs, I think Blackberries and some of those things were prevalent at that time. I'm dating myself here. And we did an analysis of that. I brought that product in. We delivered on that application, and that became another huge success. So that was the genesis. So out of the background work and data validation, we had a second version. And that application actually, if I'm not mistaken, Intelligent Enterprise, if I'm not mistaken, gave that application one of the best BI application in that time. I think it was 2004, if I'm dating myself correctly. And so we got that with Cisco and Siebel at that time. We got that. Eventually, the Siebel got acquired by Oracle, and hence my transition from data engineer at Cisco to product manager at Oracle, because I was one of those guys who understood the ins and outs of that particular product that became Oracle BI. And then I ran that product management for the next 4 or 5 years, till 2010. So that was my transition from engineering to product management in Oracle.
Nice. So, I mean, you told us about that kind of stack, right, in the very early days. So having like this kind of like Oracle database, generating static HTML, loading that in the browser, like take us through data volumes here, right? Like if you still remember, like because this was big data back in the day, right? Like kind of what was big data actually then in the late 90s and early 2000s?
Cisco was actually on the pioneering of that. So big data in those days. So the thing about Oracle applications, SMP infrastructure was, you can only scale so much. I think it was one single box, 64 cores, if my memory is 32 cores or 64 cores, I don't remember now. And it probably had about 256 GB or maybe even memory. I have no idea. I think it might be less than that. And it was expensive machines, upwards of $1 million for that one single box, right? And $1 million then were much more expensive.
I mean, the like just availability of like that type of hardware nowadays, of course, like that's not considered a big box, right? But like, sure, like more than 20 years ago, that's absolutely insane.
Yeah. And on top of it, it was shared everything. And so our process from midnight to like 6 a.m., we would take up a lot of processing power. So we would ask nobody else run it, but then there were still conflicts. And when the conflict occurs, there wasn't an easy way to troubleshoot, right? Because everything's there. So we'd have to start killing other applications. In some time, they would kill our application too. But ours was the HOV lane. Ours was like the ER lane, right? We would get high priority, high visibility. So that was good to have. But it was also bad because if something happens, I would be on call the next day morning with the VPs and the directors in their offices trying to figure out why I did what I did and sleepless nights to fix all that. So in terms of data volume, going back to your question, so it was internal Oracle applications. So there wasn't a lot. But again, we have a lot. So if you expand our bill of material, there was a lot of transactional level details. Probably closer to like 20, 30,000, maybe not, maybe about 100,000 records per day. And we used to do this 3 times for 3 different time zones, Asia Pac, EMEA, and the US. And the US was big. So about 100,000 records per day. The challenge was not the number of records. The challenge was trying to get to an accuracy and a lot of things. So people are entering data on multiple different terminals. Orders come in and vendors will load in that information. Somebody fat fingers and instead of 10, they put 2 zeros or they put a different number. Executives don't want to see that, and because it would throw off their numbers. One thing I realized in this whole conversation was before, at the time of BI, and even today it's true, people who really know the data, who really are the business, what engaged with the business, they intuitively know that data better than us engineers. So why I say that? If there was a fat finger, if there was a number that was incorrect, I would get a call from the SVP of sales or the particular region and say, this number is wrong. I know this cannot be the truth because I have not seen this. I would have known this. So any which way, they were almost always correct. So we would have to, our challenge was to make sure that those kind of numbers in the upstream system, impacting the upstream system, does not automatically flow through. So we had to build some triggers and metrics. So our processing and data accuracy with lack of actual tuning, all these things were just getting started in pre-internet days. How do you build a reliable data pipeline? How do you build data accuracy? And at every stage of your data transformation, how do you put in controls and alerts in place? I think that was the biggest challenge. And that was what took us longer. But in the end, I am a big proponent of data controls, data governance, and notification, and QC for data as a separate entity. But we did a lot of work on that internally. But that was my biggest learnings in this whole process.
Gotcha. It's so crazy to me because like so many of the things you're talking about from kind of back then in the early 2000s, right? Like they're just as relevant today. And if you talk to data engineers today, they're struggling with similar things like data quality, data observability, kind of all of those things, just of course at a different then scale in many cases. Do you think we've come a long way? Like if you look back, or do you think the problems are actually just the same in many cases?
I'm still struggling doing the same things that I used to do back in 25 years ago, now in my new role at BlackRock. So no, what has happened? I think it's interesting to look at the shift that happened in 2010. So before 2010, data warehousing was a big thing. Data modeling was a big thing. Bringing data in and making sure that the data goes through a certain rigorous data modeling, data accuracy, data validation was big, to the extent that it actually stifled some of the data volume movement, for lack of it. So there was a data explosion happening on the periphery with internet and the logs. But then there was this use case where decision support systems, as they were called in the past, they were going through a certain changes. They were immune to that other world. So you had certain things like people like us who were building this by hand and taking our sweet time. So building a data warehouse would be a two-year effort, right? And it was granted, like, hey, 2 years effort. If you want to make a change to a dimension or bring in a dimension, that's a 6-month effort. And everybody lived with it. And then suddenly this whole data explosion came along in 2009, 2010. And tangentially, MPP became a huge deal, massively parallel processing, analytical databases. So back to 2000, 2005, there was one database for all, like the one thing for all. You either choose Oracle or you choose Sybase or you choose Microsoft. They all did this OLTP extremely well. And then as an afterthought, they give you this big hunk of a hardware, single SMP, single instance hardware that you could just take the data from your OLTP, do your ODS and do your data warehousing and scale. That was your data warehouse and that was your scale, right? You do all the magic was in data modeling. MPP came along and they broke that paradigm. And they said, you don't really need this big infrastructure. You just load the data and let it scale. And so if you are doing trending and if you're bringing data from logs or if you're bringing data from machine generated and you're doing trending data, great, that works awesome. And so it became a huge success. So you could do things that you could never do before. You could never get tick stream applications or log analytics, great applications, but you couldn't do that within a reasonable size and within a small budget. You couldn't do that. But what it also brought in along with that was this whole concept of data lake, which eventually turned into data swamp for many people. But that, I think we are now about 10 years after, we are now starting to realize that. We are starting to realize that, no, you can't just scale your data and your infrastructure, good as it may be. You also still need data models. You also still need data quality controls. You also need data governance, and right? There are vendors who are now doing it at scale for cloud, which in the old world, mostly done by Informatica on a single node machines. And that's why I think we're seeing a lot of differences now. So to your original leading question, going back to that, I think this next few years, you're already seeing a lot of that hype. You're talking about data observability, which is pretty much this, right? Data observability goes across the board. not just on availability, but also on notification and processing time and QC, governance, data maturity. I think those will come into play. I think we are ready for that, but we don't have a good technology today, in my mind, that solves for all of that. I also think because of the volume of data, there are potential AI ML use cases, right? Which can look at historical data, observability being one of those cases where you can actually bring in a good quality data QC or a data governance model that can give you early warnings so you can build on top of it. You can actually be much more effective now than you would have been 10 years ago. And I'm very optimistic about the future. We are trying to do some of those things in my current application, because if you see my past, I've been doing some of the data pipelines for supply chain and marketing companies. BlackRock was a marketing company for the most part, marketing and finance. But now that I am in BlackRock and it's a financial company, that is, again, our challenges are back to data accuracy, providing the right data at the right time with good quality controls. So we are seeing that challenge again.
Take me a bit through that, right? So, right, you have this super long history, kind of, you've been in BI since the kind of very, very early days at Cisco. So now you're moving kind of into like this kind of more like financial space. And at least in my head as an outsider, right, kind of, you always, like, when you think of finance, you think of like legacy systems kind of, and then very, very high bar in terms of like data quality, right? Because, okay, like kind of like there's a lot of money at stake in this space and so on. So take us maybe through the types of data challenges you have in that space and how it's unique.
I'm still trying to figure out the uniqueness of our scope. I think a lot of times I've heard about applications and legacy applications in finance and a very hard and well-structured processes, and both of them are very true. Most of the financial applications, at least in where I'm working, the challenges are that we have very strict and well-built processes that has survived for multiple decades, and those code has not been touched for multiple decades. People have moved on, but the code's not been changed. We are bringing in modernization into this industry. So now I'm straddling between legacy code and newer infrastructure with data modernization. The challenge is we don't quite understand how we can take an existing legacy code, which has a ton of processes, which has manual input at every stage, and move it to a new technology without breaking something. So that's the challenge. I don't want to get too deep into that, but at the same time, yes, what you're saying is absolutely accurate. If we break something, the unintended consequences are very high. How do we make sure that we minimize? I don't think there will be zero unintended consequences, but how do we make sure that we can minimize those to the extent that the risk is well captured, the testing time can be extended? But that's our challenge. That's also our opportunity in terms of how we can scale. Because technology is not a challenge anymore when it comes to data processing. Infrastructure, architecture, these are all pluggable, quickly adjustable components. I think technology has governed and moved quite fast. It's now bringing the rest of the organization to validate and use this technology absolutely correctly to make this happen. I think that's going to be the challenge for the next generation.
Right. But like from a quality perspective, right? Like that sounds super interesting, because we were talking about like this data quality aspect, right? Okay, like did someone enter an extra zero here? Kind of did the distribution of my data change? Kind of is like, should I be firing an alert? I guess here you have this kind of second kind of dimension to it, right? So you're touching legacy systems, which maybe like don't have kind of a lot of observability in place, and you might not be able to retrofit that onto them. You're building something new and trying to figure out, like, does it do the job? Like, what starts going wrong when I turn off the old thing and so on? So that's
I think, so again, I think for what we do, a lot of data comes from external third parties. So we don't control anything here. And that's what I was talking about, using AI and ML to fingerprint, for lack of a better word, to look at how we used to get the data in the last few years. And if you see a large enough standard deviation, can we predict and at least quarantine the data so that you can actually have somebody look at it, validate it before you accept it? So those are the kind of processes that we are talking about. The key for that is you need to have a proper metadata. You need to have a proper governance model. because I can put a process in place today to do AI ML and look at my historical trend. I can come up with an area where I can see some exception. But to act on that and act on it real time, I think that's a bigger piece of puzzle. Getting the right infrastructure, because people who have been there are more siloed in their organization. So I think it is definitely a shift in what we are doing, but I think it is exciting in the sense that it's new, and that's the technological evolution that we are going through.
It's super, super interesting. So how big is your team, if I may ask?
We are a newly formed group called Data Platforms and Services. And my team, we manage reference data, which is kind of a fairly large amount, and it's used across the enterprise. And I have about 25 people under my team. And this is just engineers. And then we have product managers and data stewards and other operational analysts, operational engineers and things like that.
Nice, super, super cool. And also cool that you have like the kind of organizational buy-in to tackle these types of challenges. So that's awesome. In the intro, you were kind of mentioning this like data deja vu, right? Kind of seeing things over and over again. And we talked about that data quality aspect of it. Like in what other areas of like data engineering as a whole are you kind of having this like data deja vu nowadays that you had in the past?
So we talked of quite a few things, right? So what I faced in 2001 for a company financial metrics, I'm seeing that again today. So I moved organizations, but I see the same thing happening here. And there's a lot of things that I'm noticing that are consistent in those days here. Some of them is because we operate as a startup, and so there are some challenges there. But the other thing is, it's also a financial industry, and there is a very strict review. So they're very conservative in how they work on this platform. Also remember, from 2006 approximately to like recently, I've gone towards the vendor side, and I've also worked in other companies which were more open to buying vendor products. We are back here to a point where most of it is inbuilt and in-house. So that's another shift, right? So I know from a vendor perspective, there is a lot of availability in terms of tools and technologies that we could easily incorporate and put in, but that's not how we build at BlackRock. We invent, we do it here. And a lot of reasons is because we eventually end up sharing it with our client, right? So if I were to go and bring a data in, I don't have to only look at how much money is spent in buying that. I also have to license it for other users. So to make it profitable for us, we have to be able to build it and scale it to our clients. So the engineering world that I'm in recently, it is interesting because what I'm trying to do is, given all the experience that I have had, can I take my team? And my team is fairly young. Average age is probably 30. And I'm bringing the age up pretty high, right? But 30, 32 maybe. So how do I take them through this when they have one? I think part of them is mostly software engineers, not data engineers. I have to transition them. So I have to go back to dig into my old days of how I reacted to this, get them data savvy. So that's that, right? So the whole people transformation, because these are great people. So I need to translate. And then how do I also translate that into what we can objectively achieve year over year and trend better? And I've been only here for a very short time. So it's a long process. I'm still learning a lot of things and a lot of challenges, but I believe there is like I said, the next 3-4 years is going to be massive in terms of how the whole industry changes to solve for this, but also how our company is going to make a big difference. And I see a lot of potential there.
Another thing, right? We talked about it earlier in terms of the .com, right? And kind of the predictions you were seeing and so on. Like now as well, right? It's kind of like at the macro level at the moment, like not a great time, and especially for tech. So one thing which is coming up more and more kind of in conversations I'm having with people in this data space is this question of kind of like proving that all this data you're collecting is actually worth it, right? And at the end of the day, it's kind of contributing to the bottom line of the business. What are your thoughts on that?
I've dealt with two sides of that coin. So remember my pre-Greenplum days and my Greenplum and post-Greenplum days. So when it came to the pre-Greenplum days, I was like, why are we collecting data that we cannot even process? What's the value of that? Why are we creating a data swamp, right? So I have that that's part of my brain, right? But when I was part of Greenplum and I was the product manager for Greenplum, I had to put that on a really back burner and not bring that up. I had to talk about all the cool things you can do. But reality is, and this is why I think as a technical and technology industry, we didn't do a good job of educating our clients, is you can't just continue to collect data and not process them if you don't even know what exists. And the Hadoop days and the Databricks days, those days are great for technology and great for infrastructure spend, and glad that we had easy money at that time. But now I don't think that's going to fly, because even at a company like Clorox, when I joined Clorox, I didn't talk enough about Clorox, but I joined Clorox to first upgrade that, modernize that data platform, first on-prem through Oracle data warehouses and Exadata and stuff like that. And eventually I did it to migrate to Google Cloud and Azure. So even there, because we are CPG and margins are really small, there was always this underlying question: why do we need to collect so much data? How can we optimize? How can we process, right? So what I ended up doing was not only doing the data transformation, doing the data pipelines and bringing the data in, I actually ended up building a couple of applications on top of it to showcase what data means to the company like Clorox. So this ties in very well with your question, because executives are not sending any blank check at that company. We use data to try and predict forecasting accuracy for products. Can I predict how much can I sell it? So we couldn't do it really good, so that was shut down. We tried using NLP and voice interaction to see if we can predict and call out any product concerns. So that kind of worked out okay. I built a new version of executive information system for Clorox. We called it the Daily Briefing. So it was a mobile application, but pretty much following the same standard, and it was on a mobile phone. And that became a huge success. That was like my last run. And those are all built on the cloud, right? All of these things are built on the cloud. So I always worked in industries where we had a very narrow path between how much data we collect and what's the value of that data. Nobody gave me a blank check, except in my Greenplum days. Even at Greenplum, we were telling customers, no one gave me a blank check to go in and load as much data as you can. We did one project called which eventually became called the CDP, the Consumer Data Platform. And we brought in cookie information and cookie data. And I did it for about 1 year. And we were collecting about 1 billion records per day, right? When you explore that marketing data. But in a year, we could not find any valuable metric out of that. Or at least the marketing team couldn't find any valuable metric too. And we are brick and mortar. We are not very online. So it may have been better for online than us. But nevertheless, that was shut down fairly quickly. And it was all on-prem. We had a Hadoop cluster. I set it up. That goes to show there were some people who were not in the technology world who didn't buy into this whole hype on collect as much data as you want and then run your algorithms on top of it and you'll get the results. I think that did work.
So yeah, do you have any kind of closing things you want to say, right? So maybe one thing for people getting into the space, because you said, okay, you're taking software engineers now kind of at BlackRock, right? And getting them closer to like to this data engineering world. Like if I was starting today, right, kind of out of high school, kind of going to college to get into the space, like any advice from your end?
I think when I grew up, there was no Google, there was no cloud, there was no YouTube, there was no Mooch, I think, but that's what it's called, online learning, on online training, cloud, right, Coursera, and so all those are available today. So all I have to do, which makes my job a little bit easier, is point my team to in the right direction and tell them go and learn and get better. The biggest shift from software engineering to data engineering in my mind is the data domain knowledge. I possibly intuitively do that because of my past experience, but understanding how data is processed on top of the code is such a big thing, which software engineers don't care. Software engineers think of data as an afterthought, whereas data engineers think of data as the first thought, right? So how do I scale? How do I make this consistent, secure? That would be my first thing. But in terms of the learning, I think there are already so many tools and technologies in place. It's easier. It's a whole lot better today than it was in my days. Now, you might think of me as going back to the old days, but that's true. We didn't have the right tools and technologies, and I can get the job done much faster today. In some cases, you're stuck with legacy code. But too bad. We got to get that out. But I see a great potential for people who are coming into the data world. And I wouldn't have said this earlier this year, which I'm saying now, right? The AI winter is possibly near and here, but it's going to pass. There is so many opportunities with AI, with data, and with the whole data industry that we don't even know what the future applications are going to look like. Future applications are going to be driven by data. Making sure that you have the right data in the right place, processed properly, will make your company more effective, more worthwhile. I've seen this again and again and again. And like I said, I did an application in 2000 without understanding what the implications are. I did the same application at Clorox with the intention of, nobody gave me the requirement. I came up with that model. I pitched that idea to my CIO, made that success. And the whole reason was I had that background in data. I had the background in business knowledge to say, from an executive point of view, this is what they would look at. And of course, I had help. I'm not going to say that I didn't get, but trying to fine tune that, I could do that on a different technology, on a different platform, because I understood the data and the value of data and how people process that data. So data itself is abstract. Data is difficult to comprehend. Making it easier, that's the job of a data engineer, data scientist, however you want to label it, data analyst, data scientist, data engineer. Those are all different flavors of the same thing. Make sure when you are in front of an audience and trying to pitch, you understand the data, have a good data representation, valid, not biased, valid data representation that can help others see the picture you want them to see. And that itself is a big hurdle to pass. And then once you have done that, the third aspect of it is all the cool technologies that are in place. You can build AI and you can build ML, but if you don't do these two things and give them what can be the truth, what the future of the possibility, I think data will just remain unprocessed.
Is this something you can kind of learn, or you just learn kind of over time as you're doing it, right? Because especially if you're a kind of data team catering to different parts of an organization, like you will also have so many different requirements and kind of different teams trying to do different things with the data and so on, that actually catering to your audience might be really, really hard because it's just, there is no one audience.
This is probably the biggest learning I have. I come out and say, like, I know all these things. I would tell you how many times I've gone into meetings. Remember, and I can remember very vividly, I was at Clorox. And this was my first day at Clorox, first few days at Clorox. And I was pretty confident because I knew data, I know what it is, and I could talk data, right? I've done some work on it. And I went into this marketing meeting and I was kind of referencing certain things with a different terminology than finance or marketing people would reference. And these are pure marketing guys. And they're like, what the heck are you talking about? I have no idea what you're saying. Like, it was like we were talking two different languages. I had to spend time with the marketing team to go back and understand their use cases, understand exactly what they're trying to do. So I had to bite the bullet and spend time, bad as it may sound for me now to acknowledge, I had to relearn data. That is no easy answer. That was my earliest mistake. And now I'm a little bit more careful. And every once in a while I get overconfident and I try to think like I know everything till I get knocked down and said, no, you don't know. And that's always the case. Data will always have a part of it that's different than what everybody will perceive it to be. And that's the challenge. You are closest to the data, but you still don't have a grasp, I believe. And this is all coming from, this is my opinion. You will still have a grasp of the data, but it'll be contrary to many of the biases other people have built in. People have looked at, it's like I don't know if you know, and it might be an Indian term, but 7 blind men touching an elephant. That's the story of data. Somebody's touching the trunk, somebody's touching the tail, somebody's touching the legs. That's your data. The only person who actually has a full view of the data is potentially a data guy, a data engineer, a data scientist. And how do you present it to the people who are primarily biased, and biases is the blindfold, and have a view of that bias, and they are higher up in the organization. So ego is at play. So how do you do that? And there are areas where you don't confront, and there are areas that you go in and present in open-ended points of conversation, and eventually bring them along. And that's going to be the challenge. I think today the world is in a place where everybody understands that data is big, data is huge. LLMs are proving that. If you have large learning models, you can actually do a lot of fun stuff. But again, there are going to be skeptics. So making sure that you can wrap your use case, wrap whatever you're trying to do within a right information, providing both the views of it, right? So you don't want to only provide views that are validating your point of view. You also want to provide areas where it says, oh, here are the areas that I found that are contrary to my views, but these are potentially having explanation of why you think they are. Something that builds to your narrative, something that builds to your storyline is important. So end of the day, telling a story is critical. And data engineers need to get better at storytelling. Data scientists and data visualization engineers need to get better at understanding the data. I think it's a two-way street there. So together, I think we have a very strong team.
Awesome. Perfect. I think those were great closing words, Krishnan. It was great having you on the podcast. Really kind of very, very awesome. I hope you have a great day.
Thank you very much, Benjamin. I appreciate your time. Thanks for giving me this opportunity. I'm excited to be sharing my information. Take care.
The Data Engineering Show is brought to you by Firebolt. It's the cloud data warehouse for insanely fast analytics over terabytes of data with fewer resources.